So the presentation that I will be giving today is actually not my own presentation. It's the presentation from my mentor and supervisor. He's called Professor Bernard Foing. And it's about the EuroMoonMars project, which is a project group actually for students, young starters, and also some more experienced veterans in space. And the main purpose of EuroMoonMars is to sort of understand what we are here for on the planet, and also to understand a little bit more about the other rocky planets and the evolution of Earth. And one of the ways, especially to me as a geoscientist, is not actually by looking at the Earth to understand more about early Earth, but it's looking at Mars and it's looking at the Moon, because there are a lot more older rocks over there as well. So how do we prepare for going to the Moon and to Mars? So one of the main projects that Bernard worked on during his professional life at ESA, he was a senior scientist, I think, for about 20 years. Please don't quote me on that, sorry Bernard if I got it wrong. So he was a senior scientist at ESA, and he was the project developer as well for the Smart 1 mission, which is a mission which went to the Moon in 2006, and eventually also crash landed on the Moon. I think there is also an image, oh no, there's not an image of a Smart 1 crashing into the Moon at this point. So the main purpose of Smart 1 was to give a technology demonstration of how we can get to the Moon with as little fuel as possible. So actually when it reached lunar orbit, it immediately set 2 world records. The first one was for getting to the Moon with the least amount of fuel spent. So from Earth orbit to lunar orbit, they only spent about 82 kilograms for a spacecraft, which was almost 350 kilograms, which I think is very, very impressive. At the same time, they also set the world record for being the slowest to get into lunar orbit, which took about 13 months. So, I mean, you win some, you lose some. And the main purpose of Smart 1 on the lunar surface, or above the lunar surface, was actually to search for peaks of eternal light. So this is the south pole of the Moon, as some of you might already recognize. Especially here around the Shackleton crater, which is located almost dead south on the south pole of the Moon. There are some peaks of almost eternal light where there's almost 90% sunlight of the time, which means that you both have a crater, which we now know also contains some water traces. So we have water available, which you can use, of course, for plants, for food, for drinking, but also for fuel, for rockets. And at the same time, you also have almost unlimited power because of those peaks of eternal light. So going to the Moon, these are just some very nice pictures. I'm just going to skip through most of the pictures, I'm sorry. We are a little bit short on time, and Bernard always likes to give very big presentations. So this is the main roadmap of which EuroMoonMars started with. It was developed by the International Lunar Exploration Working Group, which was founded in the 90s already. And as a separate project, they started out in 2007, actually by doing analog missions as well. And eventually in 2009, they had their first analog missions in the MDRS habitat. But the whole roadmap of the International Lunar Exploration Working Group is to actually find how we can move 1 million humans from Earth to the Moon and actually survive there. Not just for a short period of time, not just going to the Moon, doing our science there and returning, but actually staying there for a longer period of time with a permanent lunar presence. So before we can do that, of course, we need some robotic missions, and this was already drafted all the way back in the 90s. So there used to be also some dates on this. I'm afraid we are a little bit behind schedule, because I think the idea was to have a lunar base somewhere in the 20s, and I'm not sure if we will actually make it that quickly, that far. But one of the things is that we actually need to have what they call a robotic village before we can actually move on to a full lunar outpost for humans. So a permanent human presence, and eventually even an international lunar base. So a lot bigger than just an outpost for just a couple of people, actually having a village. So preparing for a robotic village, as I already said, they started about in 2007, very close by actually to where the main base of the EuroMoonMars group is located, which is at ESTEC, which is the Dutch facility in Noordwijk of the European Space Agency. So we went over to Germany, to the Eifel volcanic area, and if there are any other geoscientists in the room as well, the Eifel volcanic area is quite a special area because it's located on top of a hotspot, which means there's a mantle plume coming up from all the way down to the base of the mantle, which has some very specific chemical composition, which is quite similar to what we find on the Moon. And it's also one of the very few hotspots which actually is located underneath a continent rather than underneath an ocean, because of course most of our planet is ocean. So these are just some images from some of those sort of tests that they did with some tiny rovers. They had a lander which is called the EuroGeo lander, and they were in the competition for the Lunar X Prize of Google as well back in 2012. And they were mainly focusing on cooperative robotics. So how can we use different types of robots, for example, different sizes, but also meant for different tasks, and how can we cooperate with those robots, but also how can we have those robots cooperate with each other, again, for those robotic villages. This was apparently in September 2009 already, so just after the first MDRS mission that they did. I was not a part of EuroMoonMars back then, so I'm afraid it's just going to be showing some pictures. I did become a part of some of those IVO campaigns. It's quite a recurrent campaign that we're doing with EuroMoonMars. I think we're going there once or twice a year actually. Also to collect some rock samples, to also collect some soils, and also do experiments there. So because of the very similar geochemical composition, we are also growing some plants in there. That's actually one of the big projects that my university is currently working on, the Free University in Amsterdam, to see how we can grow plants in there and actually harvest some food from there as well. And then another campaign that they are part of is actually the campaign from DLR, the German Aerospace Center, which was supposed to happen all the way in July 2020, but then COVID struck and then they moved it to 2021, and then COVID was still a thing, so now it's actually finally going to happen in June this year. But they are also practicing for the EuroMoonMars campaigns separately and also in collaboration with the DLR campaign. So with German aeronautic robots as well, such as the Rolex. I'm not sure if the image is not moving. And as I said, it's mainly based for students, for young starters, for young professionals. So we had some interns coming from Dublin, and they were playing around with some of the instruments and tools that we have, such as a multispectral camera, with drones, with rovers. And of course they went to the beach because it was in Sicily, which I think is one of the better places to go to the beach. This is the smaller Remy rover, as it's called. And we also did some tests very close by actually to Aztec. There's a company which has its own Mars yard where they sometimes also do sort of theater performances. And one of the very interesting environments that they also went to for the astrobiologist on the team was to go to the so-called mud volcanoes or mud craters. This is radio observation as well. So these are some of the mud volcanoes that we have on Mars, the Paterno, and they should also be here, a little bit here in the background of the picture, also some of the mud volcanoes in Sicily, where we did some astrobiology sort of field work to see how things in general, organisms can actually survive in these very harsh environments, because these environments are not very friendly. The water is almost constantly boiling, it's hypersaline, and there's also a lot of sulfur involved, which is highly reactive. So it's generally not a nice environment to be in. Also for our very brave volunteers here standing very close to it, it stinks. And they were very lucky actually at the end of the campaign last year in Etna. They saw an active volcanic eruption as well, which if you haven't seen a volcano erupt, definitely find a volcano that's erupting currently and go there because it's freaking amazing. So, analogs. As I already said, EuroMoonMars is quite involved with analogs. We've done quite a few analogs over the years, starting at MDRS in 2009, but we are also one of the very first commercial missions at the High Seas Base in Hawaii. And we are also currently working together with a key team and campaign in Chile to see how we can set up a high altitude laboratory there to do also some more extreme environment testings. And of course we also went to Iceland. Eventually the EuroMoonMars project turned into its own project, and this January, together with Charlotte Powles, who's still here in the audience, we founded our own company around this project, which is called Icy Space, and I think we have a talk about that in about 25 minutes. So please stick around after this talk as well, because I'm still on stage. So one of the main goals for these campaigns are not just to do research or to prepare humans to actually go to space, but it's also to give a demonstration of the instruments, of the technologies, and also to develop new protocols for these technologies so that it's actually easier to implement them when we're actually on the lunar or Martian surface. And we're also helping to develop some habitats. Just like I said, in Chile, we are actually helping to develop an extreme high altitude habitat, which will be located at almost 5 kilometers altitude. And a lot of research, so this is a lot of the instruments that I've also had the pleasure of working with. Well, some of them are a pleasure, some of them are very hard to work with. They are a little bit outdated maybe, but still it's very cool to actually get results, and when you actually look at the literature to see that some of the results that you're getting, for example, from Hawaiian volcanoes or Icelandic volcanoes, are actually very, very closely similar to what we find on the lunar surface. And yeah, I think this is just more of the experiments that we were doing. This is a very fake photo at Aztec. Yes, so as I already said, we were also one of the founding members of the International Moon Base Alliance, which is currently running the High Seas Base together with Hank Rogers. Actually, Hank Rogers is the owner, and International Moon Base Alliance is sort of helping out with hosting researchers, with finding the students, and also connecting them to the actual space world. And I've also been a part of one of those missions. I was EMIS 3, Charlotte here was part of EMIS 2. I was also remote support for EMIS 1, and well, basically since 2018 we have had about 2 missions a year where we are sending international group of young researchers, mainly students, to high seas to actually do some very cool lunar fieldwork. Such as this, where we are sitting in the middle of an AA field because our chief engineer, this guy over here, Lucas Brasileiro, he wanted to drill some rocks to see how the rocks would actually influence the drill bits, but also vice versa, before we, for example, try to build a habitat on the moon where we have to secure it, drill into the rocks without our drill bits overheating, which was a problem that I did not think of, but yeah, who am I? I'm just a geoscientist. I do not speak engineering yet. This was my research. As you can see, I'm smashing rocks, which is my favorite thing to do. And the Iceland project, which eventually was called Chill Ice, which stands for the construction of a habitat inside a lunar analog lava tube in Iceland. We had our very first scouting campaign all the way back in 2018, so about 4 years ago now, where we're joining an envoy from ESA to see if Iceland at some point would also become a member state of the European Space Agency. Talks are still ongoing. I hope that it will happen very, very soon, especially now with Galileo coming up into the air. But yeah, we'll have to see. Hopefully with Chill Ice we can also contribute a little bit to the Icelandic space sector for this. Just more pictures, but again, we will tell a little bit more about Chill Ice very soon. Then another thing with a weird R over there, it's called EMATA, which is an astronaut training academy, which EuroMoonMars is going to set up. Hopefully we will have our first courses ready by 2024, so we are still thinking a little bit further ahead, but the idea is to also have a sort of a central platform where you can train before doing an analog mission, because of course your time inside such an analog base such as High Seas or Lunaris or any of the other bases is very limited, and you do want to get the most out of the experience just because it's also a very short time. So that's one of the main goals of EMATA, to see how we can sort of do the research before the analog research. And of course also the outreach. So this was in The Hague where we took the stage when there was a citywide performance. We have a demonstrator lab which is based at Aztec as well, where we can also do analog missions, but it's now a little bit fallen behind. And we are also getting to play around sometimes in the Zvezda module. It's just a mock-up, but it's a one-on-one scaled mock-up. It's located at Aztec. So we already kind of felt like actual astronauts before we went there. And yeah, we are reaching out also to the younger generation, as you can see here. So one of the main problems, or actually there are many main problems with going to the moon and actually setting up a moon village over there, it's not just to get the humans there, but it's also to survive, it's to cooperate, it's to communicate, and it's to actually do some science as well to make sure that we are actually improving human life, not just on the moon, but also back on Earth, closing the loop, making sure that we're also giving back from space to Earth, just as we are giving from Earth to space. So for that, of course, we need habitats, which is also one of the key factors that EuroMoonMars is trying to develop even a little bit more into the future. For example, working together with ESA to see how we can have 3D printed habitats or regolith-based habitats on the lunar surface. But there's also a very cool solution, which is lava tubes, but I'm not going to spoil too much about my next presentation. So let's quickly move on. Expanding village and activities at moon bases, yeah, because eventually the idea is not just to go to the moon and to live on the moon and say, now we did it, we're happy. It's to ever keep growing, keep expanding, keep continuing further out into space. So also using the moon village as a lunar outpost before actually going to Mars, and maybe even deeper into our solar system or even beyond our solar system. So we have workshops about 2 times a year. We have a big workshop where there are about 150, 200 people coming. Usually they are at ESTEC. Unfortunately, Bernard is now retired from ESTEC, so we're looking for new locations. And we are actually having our next workshop in center of Berlin, which is from the 7th until the 9th of July. If you also want to be there, or if you live in Berlin, for example, or close by, please also give me a call or a shout out. And yeah, I'm always happy to have more people presenting at those workshops and just more people in general to start the discussions. Yeah, so this was at the Lunaris base where we did some hydroponics. I think the rest is mainly just a very cool set of pictures of, for example, the Ample missions, which are at the Analog Astronaut Training Facility, which is also in Poland. Just showing off, oh, those are cockroaches, I don't like them. Let's quickly continue. Where, of course, we also did some medical tests. I mean, it's, I think, a fairly standard analog mission for the people here, but it's always good to sort of show what the different kinds of work that we are doing. And because we are such an international and diverse group, we have experts, especially young experts again, from, for example, geosciences such as myself, but also medical experts. We have people from space economics, space law, we have hydrobotanists as well, and yeah, all kinds of teams working together to actually make the analog missions of the EuroMoonMars group into an even bigger success. This should not be the last slide, but it's not continuing. Not sure. Can you maybe press the arrow upstairs? If you can still go on. Ah, okay, apparently there are some slides hidden there as well. Okay, in that case, well, so the last few slides were actually about the Chile campaign, which was in February, March this year. I think it's about slide 52 or so where you can actually see it. Yeah, so I was also a member of that campaign. It was my very first extreme high altitude campaign. We went to an altitude of about 6,100 meters. And we mainly were studying some of the minerals over there and seeing how they are formed. So some of those white crusts on top of the minerals, on top of the rocks you can see over there, are what they call autogenic minerals, and they grow in situ, and usually they use biological processes as a catalyst, sorry. So what we are looking for is how those minerals, those autogenic minerals, form exactly, and how quickly they form, and what information then actually can contain about the paleoclimate and the paleo weather. And this is mainly important for Mars because from Mars observations we have already seen from orbit actually that there are some of these mineral deposits very likely to be present in large quantities as well on the Martian surface. So if we understand better how they are forming in extreme environments on Earth, such as at 6 kilometers altitude, where there is, for example, no liquid water anymore because there's just permafrost, there's even no active layer anymore on the permafrost, we can maybe also understand what happened at the Martian surface back in time that actually helped these minerals form. And what we can learn from that about the paleoclimate of Mars, and maybe even also a little bit more about the very early stages of Earth. And lastly, yeah, so we have some workshops coming up. We also have a summer school coming up, which is together with the DLR campaign in Sicily. It's actually the island next to Sicily. It's called Volcano, and there we're going to be doing a 12-day workshop as well. And if you want, you can also get an invite still. Just make sure to reach out to either me or Bernard, which I'm happy to give you the contacts for. and thank you very much.